Hello everyone, today we have learned we are going to create a beautiful coffee shop agent. I'll show you the output just like this. When this is a coffee shop automated agent wherein it will give you the entire details about the options available to you if you are visiting any of the coffee shops lately or recently. So you can ask the agent, okay, the automated agent. We have just created this app and deployed this app as Coffee Barista. So based on our inputs of a specific coffee shop, of the specific list of beverages available over there, like the matcha, the espresso, the frappuccino or cappuccino or whatever. So the list, we have given it accurately to our agent as the menu, and we have asked the agent not to divert from the actual list of beverages available at the particular coffee shop, okay, so that we can maintain the accuracy of our system, and the agent should only respond with the accurate information rather than hallucinating and giving vague information or unexpected outcomes. We don't want that. So that's why we have instructed our agent while creating the agent system to specifically stuck to the menu we have provided as a JSON file. Okay, we'll see how we have created this. So this is the outcome which we want to create. I have already created it, so I'm just giving a demo over here, a basic demo to how to use the RAG apps, and we have inculcated the super powerful agent development kit, which is Google's ADK, which helps us to create this agent. And we have used the agent as LLM agent, which is your large language model, and then we have used the Gemini again 3.5 flash model, wherein it enhances your responses and the information the user is asking. And we are using this model as of now. So let's go ahead and see how we can create this. So this is a basic agent development kit. We have created agent.py file, app.py, menu.json. So I'll just show you from the scratch how you can do it. So first we have created the project, my GCP cohort track automated project. Just say auth list, so it will list me my details. So as soon as I create this, I get the details, and now if I want to get the project, I will just say gcloud config get projects. So my project is already there. Now if I want to set this project, I am going to do gcloud config set project, and I'll give the project ID, which is none other than the mentioned, like my GCP cohort RAG automated agent. Okay, so you have to mention the project ID. Once this is done, your project ID is already set. Now you can proceed ahead as per the instructions over here. So we have this instructions. We have to enable the APIs. I have already enabled them, so let's do that once again. Google service enable APIs. So we are enabling Google API, then AI platform API, and then cloud build Google APIs. So once that is done, we are proceeding to the next step, and we have to set the value. So we have just set the project value, but in order to export it as a variable, we are using this export command to export it as a variable, wherein I'm going to say export project ID as, okay, then I'm going to fetch the value using the gcloud get value project. So if I'm assigning the value from the get value, and it is getting stored where it is going to set inside the project ID variable. Okay, so this is how it is done, and if you see it, export. Now I want to export the region. So region is up to you, like based on your location you can set the region. So here for the region variable, you can choose the nearest location or the zone based on your availability zone and your nearest location. So here we are just setting it as the default for now as US West 1 as the default region as of now. You have to set it as per your region. So you can set it like Asia Pacific 1. If you are in India, So I am also in India, but I'm just setting it US West 1 for this default project, since this is limited project experience which we have and limited bandwidth project. So I'm setting it as per the hierarchical project location. You can set it and change it as well. Now we have to create this. Since I have already created, so it will give me a warning on the error that this already exists. So you have to make directory, right? Make directory coffee barista agent, and we are changing the directory with cd command, cd coffee barista agent. So once see, I have already created it, so it is giving me like this already exists, file already exists, right? I showed you earlier. So if we go to the terminal and open the terminal, we can see it here, coffee barista agent is already there, right? So now after this is done, what we are supposed to do next, we have to get inside the directory and make certain changes. So as like I mentioned, we are providing the list of beverages as our menu to the agent, so that agent can pick up the information and give us the accurate results based on the menu or the available set of beverages we have provided. So here this is like kind of a JSON file. We are giving it as the input to the agent. So how we can do that? Cloud Shell edit menu.json. So I can use either the Cloud Shell, or I can just go to menu.json over here, and I'm going to give it as a JSON file which contains name, description, prices of each beverage, and tags for easy, easily searchable or easily located or traceable factors. So the name is, for example, espresso solo. Description is a single shot of rich and bold espresso, and prices like $2.5 or something, as per based on your currency. So I've not mentioned the currency over here, it's just the price which we are mentioning over here, because it could be used across it could be used globally across nations or across countries. So to keep it precise, we are just mentioning the price rather than going deeper into the currency. So you can create another billing agent where you are going to generate the invoices for your agents, and therein you can mention the currency. So here, to keep it global, so that you can share the beverages across your outlets, across your countries. So you can just go with the price. Okay, then name is like oatmeal honey latte, cold brew coffee, seasonal pumpkin latte, 5 or 6 or 7, whatever you are serving, like whatever is being served in specific coffee outlet or coffee shop, you can mention that. Okay, so we have given the description, a basic one-liner description, the price and the tags. Okay, now once you have created this menu.json file, this will work as your major input file to the agent for any of the queries asked by the customers. So this is a customer facing agent, I would say. Yes, we are creating a customer facing agent so that customer can place their orders directly by asking the queries to the agent. Okay, now if I want to validate whether my JSON is valid, or is there any errors expected on this JSON. So just going back here and coming back to the terminal, we'll just say check my file for validation errors. So it says valid JSON, so there are no errors expected as of now. If there are errors, we could have seen it over here itself, right? Now the next part is to deploy your app. Okay, so to deploy your app, we need an agent. Like I mentioned, we are going to use Streamlit and Google ADK, which is your agent development kit, through which we are going to create the agent. So these are the two tools we are going to use for creating and deploying the agent, a basic agent as of now. Okay, so edit agent.py file, I'll give this in the requirements file, my two tools. So either you can use Cloud Shell, like the command Cloud Shell edit requirements.txt, or you can just simply go to the editor and go to requirements.txt file here and add the two tools which we have used, Google ADK, the version you have to mention specifically, and Streamlit. The version, it is always preferred to use the latest version of the model. So that is something you need to research every time. Whenever you are creating an agent, you should always check the version, because sometimes there are certain dependencies which does not work, and with the outdated versions, or some dependencies which need more installations based on your requirements. So you should go with the latest version if there is, because the latest version is in sync with the latest information. I would say the updated information, the more real and updated accurate information. So that is why it is preferred. You can go with the earlier versions or the previous versions as well, but then you will not find the current data or the updated data like in real time, right? So like if you are going with the previous versions, so you won't find the information which is like in 2026. If it will be the information dated back in 2025, or maybe whenever that particular ADK version was updated, right? So that is how that is the reason why they are updating it constantly, so that your agent should fetch the latest information and accurate information and up-to-date information, and you can use it for n number of scenarios, like not only limited to the particular coffee agent we are creating. It could be any real-time news, it could be real-time analytics, it could be like the weather reports, or your news, the latest news around the globe, or your cricket analytics, or it could be T20 match analytics, or it could be anything related to the health checkups and everything related to the progress made in the medical, in the healthcare sector, or in the pharmaceutical sectors, or in schools, in education, and wherever possible, right? So that is why we prefer it. And now next step is to create your agent. So how to create your agent? You have to go to the agent.py file. In agent.py file we are going to import, again you can go either through your shell, or you can come here in the editor and go to agent.py file and start editing your agent file. Start writing the code like import.json from google.adk.agents import LLM agent. Here we are importing the LLM agent from Google. Import Gemini. So we are importing the Gemini library to access certain features of generative AI, like the text summarization, like the contextual text embeddings we are going to use from the LLM agent, and the response which we are going to generate. So all these libraries are going to help us to generate the fast responses for our agent. So we are importing those libraries first before creating the agent. Now from google.cloud.import firestore. So this is something we'll do at a later step. So this is the firestore database we are going to create next after creating the agent file. So here let's look at the agent code first. So here is my agent. I'm creating a barista agent. How I'm creating it? I'm creating it through a LLM agent. So LLM agent name, what is the name of the agent? Is barista agent. Model, like I mentioned earlier, we are going to use Gemini 3.5 Flash model. There are upgraded versions of Gemini as well, but for this particular workshop, as recommended, we are using Gemini 3.5 Flash. Instruction, like I mentioned, we are strictly instructing the agent to stick to the recommended drinks or the beverages they are offering at a specific coffee shop outlet. So instruction is, you are a friendly barista coffee shop. Your job is to recommend drinks and pastries to customers based on their preferences. Rules you must follow. So this is the instruction, kind of a manual. We are instructing the agent not to go beyond what is provided as the information. So we are limiting the agent's capability to stick to what is being instructed, rather than giving the generic answers or giving the unexpected outcomes. Okay, so number one, you must recommend items only from menu returned by get menu. Do not recommend or suggest any items if not present in the menu. If a user preference is vague or unclear, exactly one friendly clarifying question. Be warm, welcoming, and remain professional. Ground your recommendations in the actual tag, description, and legends listed in the menu. Okay, now in the tools I am saying get menu. So how will it get the menu? It is going to get the menu through menu.json. And how is it going to get? It is going to fetch that information through my tool. Where is my tool? My tool, which we have already declared in the requirements as ADK agent, right? Google ADK. Now from Google ADK.apps, import app and define the app. Name coffee barista app, root agent, barista agent. Fine, makes sense. Till here we are good, right? Now in app, what we are going to define, right? So this was the agent.py file. We have created the agent so far. Now I'm going to create the app. So in my app, I'm going to create the Streamlit app. So here we will create app.python file in which I'm going to do what? I'm just going to create the front end of my application, like how the interface is going to look like and how the user is going to interact with the agent, right? How the user is going to input their query and how the agent is going to respond. So it is kind of an interface, the front end interface or the user interaction interface which we are going to create using Streamlit app. So how would the side menu bar will look alike? Like we want to mention the menu and the name of the drinks on the left hand side, like I showed you in the output, with their prices, with their names, basically the JSON file which we have. And then on the right hand side I want to show a banner and then banner image and then the questions the user is asking with the input box and a output generated by the LLM. So this is the kind of interface we have created now using a Streamlit app with the help of Streamlit. So what is it doing? Basically, if you see, page title is coffee shop barista bot, page icon we have given, layout is white. So this is the basic Streamlit coding which we do. Import Streamlit as ST, import JSON. Now you can customize it using the themes or the color combination you want. You can stick to that, light or dark shades. Like here it is the custom CSS which we are using to style our web page or your application. Basically over here, development content, header, sticky note. So this is basic common thing. You can do it if you are a coding background. Even if you are not from coding background, you can simply copy and paste the styling options. There are many styling options available for CSS, many CSS styling options available. You can just select your one and then paste the code over here as well. Then div class, header container, text line center. So this is like whatever font you want to keep. So the basic look and feel of your website. Then we have like from google.cloud.import. Okay, so this is a Firestore thing which we are going to create the database later on. Now coming back to the front end page, so this is the side menu which we are creating using the sidebar, st.sidebar. Then the session ID. So session ID is something, it will persist your data for a specific time, like for a specific session over here, I would say. So session is, you already know, the session only exists for the specific time. Like session state is basically till the session is active. Once your session ends, the complete data is gone or your history is gone. So session state or session variables or session input or session data only states till your session is active. Once your session is inactive or you have closed your session or you have ended your session, then that session output or session data or session variables or temporary whatever information was given or extracted or fetched will be exhausted or will be destroyed. Okay, so this information is gonna state in that session state specifically. Okay, if runner not in the session state, Google runners import in memory runner. So that memory inside the session will only stick with the session input only for the time being the session is active. Okay, if message is not in the session state, then role assistant context, welcome to coffee shop, what can I get for you? So this is the basic question, the first question which the agent is going to ask. So you can code it as per your requirements. So now we are training the agent for a specific questions, like ask for recommendation, what daily, if a user is asking what dairy free pastries you have, to display username with chat message, user is going to answer based on that answer, the agent is going to fetch the similar kind of output or the available product, like the available pastry or the beverage, and then going to provide it to the user. Fine, makes sense. Next, so once you have coded your agent, and then we have to deploy your agent. So for deploying the agent, one more important thing needed over here is to create your service account. So service account is basically sticking to your agent. So you have to, every time once you want to use Cloud Run to deploy your agent, you have to create a service account. So this is kind of, you can say, a requirement. Every time your agent must have a dedicated service account, which is the need. Okay, without the service account, forget about deploying your agent. You cannot deploy your agent without a dedicated service account for your project. So what information we need to create the service account? We need gcloud IAM service account, create the name of your agent, space / description. Okay, description is optional, you can give it, display name, whatever it is. And then you have to grant the Gemini Enterprise Agent Platform role. So until and unless you are granting the AI platform role dot user to the service account, it will not be able to create the deployment. So in order to have the deployment, you have to grant this permission like gcloud projects add IAM policy binding to your specific project through which you are going to deploy your agent. Then the member ID, which is linked again to your service account and your project. So member ID is basically service account barista agent. Your project ID, like in my case it was my GCP cohort RAG automated agent .iam.gserviceaccount.com, and the role is AI platform.user, which is a generic role we always provide to each and every dedicated service account for deploying the agents on the Cloud Run. Okay, next is like how to deploy it. We already know this will take time. Initially this has never worked for me in the first case, although it should take few seconds or a couple of minutes, like 3 to 5, but eventually with time you will learn this. Sometimes it works in one go, sometimes it takes 2 to 3 times to figure it out. Like if you have provided the accurate values over here, like here you have to change the region. While running your code or deploying your code, the Cloud Run will never be able to fetch it from the variable. So in here you have to change this. You have to give your region, the specific region allocated to your project ID, or you are using, or the location based wherein you have created your project. Then labels, it's optional, you can give it Codelab Streamlit RAG ADK. Allow unauthenticated, it's like anybody can access this. So basically this is for globally accessing or publicly allowing public access. When you are putting it allow unauthenticated, okay, so unauthenticated, anyone can use it without the authentication. So that is one kind of a thing. So if you do not want that, you want to keep it private, you should not use this option. Okay, unauthenticated is like you are going global and your link is publicly accessible. Then the command is like CNB lifecycle launcher arguments. So sh python 3, we are using this streamlit run app.py server port. You have to mention the server port over here. Generally it is recommended to use the default port like 8080, or otherwise if you have a specific port number, then you should mention that as well. So again, it is not going to fetch this information from the variable itself. So server address, server enable course, server enable except protection false, service account. Again, you have to mention the service account with your project ID. That is like in my case it was my GCP cohort RAG automated agent .iam gserviceaccount.com. Then set the environment variables, which is Google Gemini use Vertex AI is true Google Cloud project. Again, you have to mention over here the project ID. Like I have also mentioned my project ID, which is my GCP, this one. If I show it, my GCP cohort RAG automated agent. So if you want to see, I can show it here. Yeah, here it is. Can you see that? I hope this is visible. Yeah, barista agent SA my GCP cohort RAG automated agent .iam gserviceaccount.com. Make sense? Yes. Again, coming back, then the role, which is a must require, like I said, the role is the Google Cloud location. You should not give the global location. I have given my project specific location, so it will be available and accessible there. If you want to keep it global, you can keep, but it is generally recommended to keep it to your specific location. If you want to launch it globally, you are good to go. You can do that, but ultimately you have to check it out. Okay, then last but not the least, we are going to test it out. Like here I have tested the app. Like here we have tested the coffee shop app. So this is my Streamlit basically, which is enabling this front end to fetch the data using the agent .py file and fetch the data for my agent using menu.json. So this is the Streamlit app coding which we have done, and your agent is launched using ADK. Now after this, we have to create a file store using vector store search. I mean, this is optional, but if you want to learn more, you can go with the fully managed databases. Like Firestore is a fully managed database. Okay, here using vector search. So in the production scenario, menu.json file is not ideal to any change in the menu, because if you are going to change the menu, how you are going to check whether the information is correct or not? Every time you have to deploy it again. So that is not a recommended practice. So in that cases, going for production, since this was just a test chatbot which we have created, but for the production it is recommended to create your database, which is your Firestore. So for that we have to enable the API, number one. Then like I mentioned, we are going to use the text embedding model over here, text embedding 004 model. So what will it do? So this will execute Python seeding script to load menu item. So it will load the menu item using what? It will read the text. How it will read the text? It will extract the data from the text. It will read the text. It will parse the text, and it will read, it will parse, and it will load the data items from the menu items using text embedding 004 model to populate vector database fields. So inside the vector database, it will parse, it will read, it will parse, and it will load from the menu. Okay, then build. Third option is build vector index, which is again very important. Why do we need to build the index? So basically, index is like whenever you have any file to read. For example, you have a PDF, you go to the index page, and then you find, okay, I want to read specific topic. I'll go to page number so and so. Okay, so here similarly, the vector index will enable me to go to the particular target or enable low latency. It will find the specific similarity based on the question being asked by the user, the input given, the input query by the user. It will, based on that, it will find the similarity. It will perform the similarity search and find the extract information, or it will find and extract the information from the menu, and then it is going to produce the result. How it will produce the result? Using the fourth option, which is find nearest query. So rewrite get menu to generate query embeddings and use Firestore Cosine vector search. Okay, Cosine vector search. So what will it do basically? What is it happening over here? So configure a composite vector index in Firestore on the target collection, enabling low latency semantic similarity search, and rewrite get menu generate query embedding to use Firestore Cosine vector search. So it will perform a vector search in a way that it will try to fetch and extract the information based on the similarity search, based on the user input and the similarity search. It will find the nearest matching or the possible matching output, and then it will fetch that information from the menu on the vector database, and then using the find nearest query, it will produce the results. Okay, so first of all, what is needed to create the database? Again, you have to enable the APIs. Whatever you are doing in Google Cloud, you have to first enable the API. No matter you are using Google APIs, you are using Google Gemini, you are using ADK agents, you are using any of the databases, you should enable the API. Again, the same applies to Firestore as well. So we are creating a Firestore database, so we have to enable the Firestore API. How we can enable that? We can enable that in the shell, or we can go to the Firestore database and then click on enable API. Or here it is the easiest command. We can use gcloud service enable firestore.googleapis.com, the name of your service or the database, then googleapis.com, and then gcloud firestore database, create database coffee menu region. So like here I've already created it. It will not allow me to create it again, so I'll give the region as US West 1. So it will tell me this already exists. I've given this command, but see, it is saying this already exists. Firestore database create. This already exists. Okay, okay, I've already deleted this. Okay, fine. So it has created this. No worries. Okay, then Firestore with menu. So the basic requirement to seed your Firestore database with the menu items, menu.json, we need a Python script. So for Python script, we have to install Python version, which we are using Python 3, and Firestore database version, which we are using 2.27.0, and Google Gen AI. So we are using the generative AI Gen AI library as well. Okay, Google Gen AI. And so these are my tools. We have to add it in the requirement files again. We'll add it in one go. Now in seed.py, what we are doing, we are creating a Firestore database basically as a client. So inside the DB, I'm going to, first of all, I'm going to import the libraries like import Gemini, import Firestore, vector import database. Now I'm creating a database variable where I'm going to store the information as, or you can say a dataset, where I'm going to store the information as file store the client database. The name of the database is coffee menu client Gen AI. Vertex AI, I'm enabling the Vertex AI so that it can fetch the information to the automated process here. Project OS version, it will read the OS information and fetch the project ID .get project ID. Location, it will again read it from the environment variables like operating system environment .get. Region, and you are mentioning it as your central one over here with open menu.json rsf menu item json.loadf. For items and menu items, use the name document ID. Document ID is item name, so I'm just using the lower function to and replacing all the spaces with a hyphen. Okay, so I'm lowering it down. The name, I'm converting it to a lowercase. In text to embed, I'm using the text embedding function, text embedding 004 model. The item name and the item description like we have inside the menu, like matcha, coffee, espresso, solo, whatever, and the description, it will fetch that information, and response it will create how client.model.embed content, which model we are creating, text embedding model, the LLM, and then contents text to embed. So this will embed the text, then embedding response embeddings starting from the index 0, the first value, dot values. Okay, now item dot embedding. Okay, here we have fetched this embedding, right? The embeddings which he has already created to embedding which it has already created to generate query embeddings, right, into the Firestore. So here it will do the vector embedding, and then it will collect db.collection menu document.id.set item. So based on the extracted embedding, text embedding, whatever information it has stored inside this embedding, whichever is matching inside my db database.collection menu document doc id and set item id. So now it is going to print it. So we are going to print Firestore menu collection seed with vector embedding successfully. Okay, it will generate vector embedding for each of the menu items. Okay, then I want to run this file. We can run it using python3 seed.py in the terminal, and then the major thing, which is to create the Firestore vector index. So to perform vector searches on your menu, you must create a composite vector index embedding field in your Firestore database. So how to create that? We can use gcloud Firestore index composite create collection group menu query scope collection database coffee menu field config. So this is the basic, the Google standard way of writing your composite or creating your composite vector indexes. So you should stick with the standard how to write this, or you can just simply copy it out. If you know more, you can change the dimensions over here like 1052 or something like that. I'm not sure. I mean, we used to do this 1052, 1082, something like that. So it is recommended to use the smallest one, 768, which is the standard one. You can refer to the document page over there, Google Docs. Now grant Firestore access to the service account. So again, before deploying your services, you need a dedicated service account. So for Firestore also, you need a dedicated service account. How you can do that? And you have to grant the user role as well. So gcloud project add IAM policy binding project ID. In my case, the project ID is like, I already have this, right? So you can just change it over here. Role is datastore.user, which is fine, and the member project service ID, you have to change this over here, and you have to give it as my GCP, the project ID which is there, and GCP cohort automated agent. And again, you should mention the same inside the project ID variable. You don't need this. Here we are giving my GCP cohort is auto edit agent and then let's execute the same. So once this is done, your project ID is assigned, your role deployment role is assigned, which was roles data store.user. Now again, do the same thing in the requirements. We have to add both the tools which we have used, Google Firestore and Gemini. So I've already done that, like I showed you earlier in the requirements file. So we have added 2 more tools apart from Google ADK and Streamlit. We have added Cloud Firestore and Gemini. Whatever tools you are using and the versions you are using, you have to mention it in the requirements. Then agent.py file. Now here we will train the agent basically. Import Gemini. So we are importing few libraries. Import Firestore database. And now here I am Firestore v1 based distance measure and import vector. Now inside the query, retrieves coffee shop menu items matching the user query. Okay, the semantic search is being applied over here, matching the user query. So it is going to retrieve the items asked by the user, like it is asking a coffee, a espresso, a matcha, a latte, or a cold coffee, whatever the user is asking. Based on the user input, it has created the text embeddings, like one for latte, one for tokens, or basically you can say the tokens are being generated. So that token will match, like the specific token is going to perform the similarity search and it will match the token inside the menu item. So if the latte is matching with the latte asked by the user, or green latte is, or the green matcha is matching, or the espresso, solo espresso is matching, or cappuccino is matching, or frappuccino is matching, whatever is matching with the user input, it is going to extract that information from as the embedding or the token from the menu, and then it is going to perform the search query preferences, matching it exactly based on similarity search, and then it will return the response as a JSON string. So this is just try and throw a code wherein it will generate the exception that if there is nothing matching with the input asked by the user input query from the customer and the data present inside the menu, nothing is matching, so we will generate an exception as could not retrieve the menu. And if there is a matching, it will give and generate all the matching possibilities, like there are 5 sets of espressos, or 5 sets of matchas, or 7 sets of cappuccinos, whatever is available, the beverages matching with the user input query. It is going to fetch that information. How? DB. So inside the DB client database coffee menu, client Gemini client response, it will generate like client.models embed content model text embedding, like I showed you earlier. So this model we are using text embedding model, so which will help us to perform the similarity search and extract the data based on the similar tokens or the similar embeddings being generated. And contents is query. So query vector will generate the response dot embeddings, so it will generate the embeddings dot value. Result, how will the result display? db.collection menu, find nearest, so the nearest possible matching. Vector field, embeddings query vector databases, distance measure, cuisine, limit 3 stream. For doc-in results, item doc to dict, item.pop, embeddings none, menu data append, return json.dumps, menu data except exceptions as e, return json.dumps, whatever. Okay, and this is how it is working. And then you can just upgrade your app.py file, like I have done it here after the agent.py file. And then we have the app.py file here. Okay, inside the app.py file we have updated it here. Yeah, this one. From google.cloud, import Firestore. We're just adding the Firestore details over here. Okay, try and accept error loading from the menu if there are no items matching, or if there is matching, then it will give it as a collection. Okay, so doc and docs, doc to dict, item.pop, embedding none, menu items append. So it will generate a list and add all the items which are appended or added. Then we have to redeploy. Again, for the deployment you have to provide the region and your service account name with your project ID again. And again, the region, you should give it your specific location rather than global. And this is all about it. Firestore integration, so it will give you the result, and you should recommend the practice to delete all the resources if you're not using it further to save your cost and minimize the cost. That's a recommended practice. And this is how I have completed this lab, and this is my output which is being generated. My GCP RAG chat automated agent. Here this is already generated, like you can see it here. Okay, and this is our deployment, the final deployment which I did. Okay, hope you will also like and learn new things. Like I learned new things about vector databases, RAGs, and how to inculcate and integrate Firestore within my agent chatbots. I've worked on Firestore earlier, but I have never worked using the RAG and vector databases and using the agent to work on my Firestore database. But this was something new, and creating this using a fully automated system was appreciable to learn this. I hope you also like this, and we are gonna meet very soon for learning more things. Have a nice day. See you later. Bye bye.